Welcome to Maths with Bob. Today we are looking at a complex number problem. We are told that z1 minus z2 equals 3 plus 4i and z1 plus z2 is equal to 4 minus 3i, and we were asked to work out what sort of quadrilateral the vertices 0, z1, z1 plus z2 and z2 form. Now I think the first thing we'd put in, let's put in 4 minus 3i. 4 minus 3i would be, let's have a look, 4 minus 3i. Somewhere down here, okay, this is going to be 4, okay, minus 3i, okay. I'm going to represent this by a vector, okay, so I then put a vector in, so I'm now going to represent that complex number point by a vector, okay. Let's mark in the origin, okay, yes, the origin, we know obviously the origin's over here at 0. Okay, now, we now need to work out where the complex numbers z1 and z2 are, and we can see that, if we actually add the two equations, we should be able to get 2 lots of z1 is equal to 7 plus i, so we should be able to see that actually z1, okay, let's work this out, okay, z1 is equal to half of 7, 3.5, plus a half of i. Okay, let's mark in z1, 3.5, okay, plus a half of i, so it's over here somewhere, z1. Okay, let's try and work out where z2 is. Well, if we subtract them, you'll find that z2 is equal to a half minus 3.5i, okay, so where's z2? It's down a bit below 3 here, somewhere here, okay, so this is going to be z2. Now actually, let's represent these by vectors as well, okay. Here we go, vector, another vector. Okay. Now, basically, we know that 4 minus 3i was actually the vector. Let's write it on. So this was z1 plus z2. Now, how we normally get these addition of vectors is we form the parallelogram. Let's actually show you quickly. Okay, we normally do a parallelogram. It's a bit rough here, but we normally find a parallelogram type thing, join the vectors head to tail to get the addition of the vectors z1 plus z2. Okay, so we can see that this actual shape, if we actually join up all of the points here, would in fact be a sort of a parallelogram. Okay, so let's actually just join them up now. Okay, so let's actually form some vectors. Another one, okay, this one would be parallel to z1, this one would be, okay, all right. Okay, although it may not look like a parallelogram, that's supposed to be a parallelogram. Okay, so now, where is this other vector? Okay, z1 minus z2. Well, from our vector work, it starts at z2 and goes towards z1, so I'll just draw that one in too. Okay, we'll actually draw that in. Okay, here we go. Okay, so that's the vector. Okay, this is the vector here. That's going to be actually z, okay, 1 minus z2. Okay, it's a free vector. Okay. Now, okay, so we now have that we've got these two, there's z1 minus z2 and z1 plus z2 as diagonals of this quadrilateral. Okay. Now, what do we know about these diagonals? Well, let's have a quick look. Well, it looks like their lengths are the same, so let's write that down. Z1 minus z2 actually is equal to z1 plus z2. Okay, it's supposed to be z2. Okay, now what would that equal? Well, it's equal to the square root of 3 squared plus 4 squared, or the square root of 4 squared plus minus 3 squared, which is the square root of 25, which is just 5 units. Okay, so we know that these diagonals are in fact of equal length, and now we're just going to try and work out, okay, what angle do they intersect at? Well, it's a bit hard to tell, but if we look at 3 plus 4i, and if we multiply it by i, so let's go, let's multiply the other one by i, 4 minus 3i, I should say, maybe it's better to look at it like this. If I actually get 4 minus 3i multiplied by I can actually, you should be able to see it's actually 4 times I, which is 4i, and I times minus 3i is actually minus 3i squared, which is plus 3. Okay, so these two are equal. Now if we take the arguments should be equal. So the arg of 3 plus 4i should equal the arg of I lots of 4 minus 3i. Okay, you might be able to see where this is going now. Okay, so we see this is the arg of I plus the arg of 4 minus 3i, okay, which is equal to pi I2 plus the arg of 4 minus 3i. Okay. All right, so okay, you can see here that Z1 minus Z2, if I actually add pi on 2 to the argument, I'll actually get 4 minus 3i. Okay, and show that. Okay, so let's actually grab this vector, okay, and rotate it 90 degrees. Okay, oops, and show you. Okay, so see what happened was we actually added 90 degrees to the argument of this one, which would be in fact rotating it anti-clockwise. Oops, oops, I'm trying to have a bit of trouble here trying to grab this vector again, but okay, let's put it back. Okay, all right, so we know that these are actually intersecting actually at 90 degrees. Okay, so it's a parallelogram with the diagonals of equal length intersecting at right angles. Okay, from this we should be able to conclude that it's actually a square. All right, well, thank you very much for watching, and we'll try another problem later. Bye for now.